Welcome to this extensions tutorial for Incisor. In this tutorial, we'll cover what Incisor extensions are, how to build extensions, and basic examples of extensions use cases. Along with its rich library for creating interactive user experiences, Incisor also offers a powerful set of tools for streamlining and optimizing the production process. Incisor extensions are a key part of this. Incisor extensions let you write scripts for the Incisor inspector and environment, making it easy to integrate custom workflow tools directly into Incisor. Since the inspector is built using the same core Incisor API, creating custom tools works seamlessly with the same reliable API you use for standard projects. To get started with extensions, just create a new project in Incisor. You'll notice a Project Extensions folder in the Utilities directory of your project, and inside it, there's a sample projectextensions.js file. This file includes a series of commented examples that demonstrate how to use the extensions. We'll begin by uncommenting the code and observing the changes in the Incisor inspector. The first thing you'll notice is that new menus have appeared in the inspector. These custom menus are generated from the sample projectextensions.js file. If we take a look at the inspector panel options, you'll also see that a sample custom panel has been added. This demonstrates how you can create your own custom inspector panels using Incisor extensions. Now, let's take a closer look at how the sample project extension script works. You'll notice the main object for functionality in Incisor extensions is called NCE, instead of the NC you're used to in regular projects. NCE stands for Incisor Extensions, and while it shares much of the same functionality as NC, keep in mind that NCE runs in its own context within the inspector, so it doesn't behave exactly the same as NC. Extension scripts typically consist of two parts: the main definition section and the run before init section. Class definitions should go in the main part of the script, while runtime commands are placed within the run before init section, which is marked by the code properties run before init begin and run before init end. One of the easiest ways to add accessible extensions to the Incisor inspector is by adding menu-triggered function calls. The menu examples in the sample project extensions file define a class called myExtensionsFunctionality class, which contains two member functions. Then, within the run before init section, an instance of the myExtensionsFunctionality class is created, and its member functions are added as menu item callbacks using nce.addInspectorMenuItem. In this function, an array containing the menu path is included to specify where the menu callback should appear within the inspector menus. In this case, the callback functions display simple alerts, which is a basic built-in function within the Incisor extensions context. To show a basic alert, simply call nce.alert, passing in a string for the title and a string for the body of the alert. Now, we'll look at how the example defines a custom inspector panel and registers it with Incisor to make it available in the GUI. The first step is to create a new class that extends the inspector panel class. Be sure to include a constructor that calls the superclass constructor, which in this case takes the name of the new custom panel. Inspector panel is a class that extends scene object and provides the basic elements for an inspector panel. Inspector panels include all the members needed to define borders, menu bar features, and standard panel functionality. However, the most important properties of inspector panel are header scrolling panel and body scrolling panel, which define where the content for custom panels is placed. In the sample inspector panel provided, simple text is added to the header scrolling panel, while several built-in GUI items are placed within the body scrolling panel. The items placed in the body of the example inspector panel include a UI collapsible stack, UI buttons, a standard UI drop-down menu, and a UI graphic button. Each item in the body is connected to functionality defined within the inspector panel class, including the use of built-in panel types, a custom panel definition, screenshot functionality, runtime project analysis, file I/O, and built-in loading visuals. Once we've defined our inspector panel, we can use nce.register_inspector_panel-definition to add it to the Incisor GUI. This makes it available for users to select from the panel type dropdown. In general, inspector panels provide an open sandbox with full access to both the project and the same GUI functionality that the Incisor inspector uses, allowing you to seamlessly integrate almost any custom tool into Incisor. Extensions also allow you to run commands when the inspector connects to or disconnects from a project, using the nce.add_project_connection callback and nce.add_project_disconnection callback functions. Functions within extensions can also be triggered right before or after a project is published, making publishing procedures fully automatable. Simply use nce.add_pre-publish_callback and nce.add_post-publish_callback. Project extensions create functionality specific to a given project. To apply the same functionality to all Incisor projects, simply place the extension scripts in the Global Extensions directory inside the Incisor Application Support folder. This concludes our tutorial on extensions within Incisor. Check the link in the description for more tutorials. And feel free to leave questions and feedback on Stack Overflow and our subreddit. Enjoy creating with Incisor.